Actually, there are different types of waveguides: cylindrical waveguides, rectangular waveguides. The basic waveguide is a rectangular waveguide. So that a rectangular waveguide looks like this. Suppose this is y axis. This is x axis. This is z axis. Rectangular waveguide is in a form like this, is in the shape. These are the walls of the waveguide. These are walls of waveguide. This is length A. This is 0. This is height B. Length and width B. Walls of the waveguide. So the rectangular waveguide shape is like this. Generally, we will assume waveguide is filled with, for our analysis, waveguide is filled with air. The first one. And the second one is the walls are perfectly conducting. Perfectly conducting. So these are the two assumptions we are making for the analysis. Here I am not going for the entire derivation of a waveguide. So I am mentioning only some important equations which are useful to our study, particularly examination point of view, gate examination point of view. For this, the first one is transverse magnetic fields, TM mode, transverse magnetic mode, transverse magnetic, that is TM modes, we will discuss. Directly I am mentioning here the equations of transverse magnetic modes of a rectangular waveguide. So TM mode means EZ is not equal to 0 and HZ is equal to 0. EZ is not equal to 0, HZ is equal to 0. That Ez in the propagation direction is given by some magnitude E0 into sine m pi by a x sine n pi by b y into e power minus gamma z, where e power minus gamma z is because of propagation direction. This is because of propagation direction, where m and n are integers, and the relation in terms of the relation between gamma m n is given by gamma square plus omega square mu epsilon. Gamma square plus omega square mu epsilon is m pi by a whole square plus n pi by b whole square. So whatever the equations we are mentioning here, you have to keep in mind, because the only important equations we are mentioning here. So gamma square plus omega square mu epsilon is equal to m pi by a whole square plus n pi by b whole square. Here m and n are integers. Each set of integers m and n gives a different field pattern. Each set of integers m and n, because m and n may take different values. So because m is equal to 0, 1, so on, n is equal to 0, 1, so on. So it will take different values m and n. So each set of integers m and n gives a different field pattern or mode. Different field pattern or different mode. Referred to as TM MN mode. TM MN mode in the waveguide. TM MN mode in the waveguide. So in this TM MN mode, integer m is the number of half cycle variations in the x direction. Integer n is the number of half cycle variations in the y direction. The y direction. So these two are very important statements, where m is the number of half cycle variations in the x direction, n is the number of half cycle variations in the y direction. Since this is a TM mode, so TM mode means what? Ex exists, Ey exists, similarly Hx exists, Hy exists, Ez exists, and Hz is equal to 0. So Ex, Ey, Hx, Hy, Ez exist. Here we have given only equation for Ez. Another important point here is, of course I am not giving equations for this Ex, Ey, Hx and Hy. So you refer any standard textbook for these equations. For m comma n, 0, 0, 0n or m0, for these combinations all field components vanishes. That is, if you substitute m and n values for this, all field components vanishes. That is, if any one value is 0, because it is all the terms are in terms of sign, you will get sign 0 is 0. So all field components vanishes. All field components vanishes. Thus neither m or nor n, neither m nor n can be 0. So this is very, very important point. For mn 0, 0, 0n or any value, if either m is 0 or nor n is 0, all field components vanishes. So this cannot be 0. Therefore, what is the first possible field? Tm 1, 1. That is for m is equal to 1, n is equal to 1. This is the lowest possible field. Okay. So Tm 1, 1 is the lowest order mode of the lowest order mode. lowest order mode of all Tm Mn modes, which is very important point. So Tm11 is the lowest order mode of all Tm Mn modes. So this is the first mode existing for Tm waves on a rectangular waveguide. We know that one important relation already we given, gamma square plus omega square mu epsilon is equal to m pi by a whole square plus n pi by b whole square. Gamma square plus omega square mu epsilon is equal to m pi by a whole square plus n pi by b whole square. Therefore, gamma square is equal to what happens? M pi by a whole square plus n pi by b whole square minus omega square mu epsilon. Gamma is equal to square root of m pi by a whole square plus n pi by b whole square minus omega square mu epsilon. This is a propagation constant. Gamma. Now we will consider different cases. Case 1. Case 1. If m pi by a whole square plus n pi by b whole square is equal to omega square mu epsilon, what happens? Then gamma is equal to 0. Implies gamma is equal to 0 means gamma is equal to alpha plus j beta. Gamma is equal to 0 means implies alpha is equal to 0 and beta is equal to 0. Beta is equal to 0. So that is attenuation constant 0, propagation constant, attenuation constant is 0, phase constant is also 0. So phase constant is 0 means there is no propagation at all. There is no propagation at all. So no propagation. No propagation. No propagation. The value of omega, because here omega square is equal to, m pi by a whole square plus n pi by b whole square is equal to omega square mu epsilon. The value of omega that causes this means no propagation. That causes this no propagation is called cutoff angular frequency. Cutoff angular frequency, omega c. Omega c. That is, we are indicating with a particular value, omega c, the omega, particular value of omega c. There is no propagation. So we can simplify it as further. Then what happens? That implies m pi by a whole square plus n pi by b whole square is equal to omega c square mu epsilon. Implies omega c square is equal to 1 by mu epsilon into m pi by a whole square plus n pi by b whole square. Implies omega c is equal to 1 by square root of mu epsilon into square root of m pi by a whole square plus n pi by b whole square. But 1 by square root of mu epsilon is nothing but, suppose free space you consider, c is equal to 1 by square root of mu epsilon. Therefore omega c is equal to C into square root of m pi by a whole square plus n pi by b whole square. Omega C I can write to 2 pi fc is equal to C into square root of, take pi square common, pi square if you take common, m by a whole square plus n by b whole square. Further simplification of the equation to make it in a simple form implies what is fc? fc is equal to C pi square out, pi only, 2 pi square root of m by a whole square plus n by b whole square. So fc is equal to C by 2 into square root of m by a whole square plus n by b whole square. So this is the equation for cutoff frequency of any mode. Just to substitute the value of m and n, where a is width and b is the height. B is the height of the waveguide. C is 3 into 10 power 8. 3 into 10 power 8 meter per second. That is free space velocity. Suppose if any dielectric constant is given, then C by square root of mu or epsilon. So we can calculate easily for any medium also. So this is the formula for cutoff frequency. This is the FC. FC is equal to C by 2 square root of m by a whole square plus n by b whole square. So this is the formula for cutoff frequency. You have to keep in mind. So whatever we are mentioning in bracket, please keep in mind those formulas. Because in the examination, we need these formulas to solve the problems. So the cutoff frequency is C by 2 square root of m by a whole square plus n by b whole square. The next one is case 2. So the basic equation we started with this, gamma is equal to square root of m pi by a whole square plus n pi by b whole square minus omega square mu epsilon. Now in the second case what we are doing, if omega square mu epsilon is less than m pi by a whole square plus n pi by b whole square, then what happens? So obviously the gamma value is positive value. Gamma is only positive. So square root of some real value. Then gamma is equal to alpha plus j beta means only alpha exists. Beta is equal to 0. Therefore, what happens? Gamma is equal to alpha. Beta is equal to 0. So in this case also, we have no wave propagation. Only we have attenuation. So these non-propagating or attenuating modes. These non-propagating or attenuating modes are said to be Evanescent modes. Evanescent modes. So omega square mu epsilon less than, that is below FC. That is this is cutoff frequency, no propagation. This is FC cutoff frequency. So this is F less than FC region, no propagation at all. So we will see third case where F greater than FC, there is a propagation. So if phase constant is 0 means there is no propagation at all. In the third case, case 3, if omega square mu epsilon is greater than m pi by a whole square plus n pi by b whole square. Omega square mu epsilon is greater than m pi by a whole square plus n pi by b whole square. Then what is the situation? If this happens, gamma values in the square root, it is some imaginary value, negative. Entire thing is negative. If you take minus out, it will be some j value. So j into something. So only alpha is equal to 0. In this case, alpha is equal to 0. Only then gamma is equal to j beta. Gamma is equal to j beta. That is, attenuation is 0. Only this is gamma is equal to j beta. Gamma is equal to j beta. So only propagation, phase constant exists. Phase constant existing means what? Propagation is there. Propagation is there. Attenuation is equal to 0. That is omega square mu epsilon greater than, that is omega greater than, that is this region, f greater than fc region. So this region where propagation exists. So here also there is no propagation. There is a particular frequency called cutoff frequency. Here also no propagation. So this region no propagation. This is propagation region. This is propagation region. That's why waveguide is called as high pass filter. That is the reason. That is the reason. Only after a certain frequency only there is a propagation exists. So that's why waveguide is called a high pass filter. So here the important thing you have to keep in mind is the cutoff frequency formula. So fc is equal to c by 2 square root of m by a whole square plus n by b whole square. So for frequencies less than fc there is no propagation. For frequencies greater than fc, propagation exists.